In this video, we're going to discuss C++ references as a special data type available in programming language. This is our presentation right here. Basically, reference is very similar to a pointer, except its usage syntax is much more like an object. So once reference is created, it's difficult to distinguish reference from the original object, whereas the pointer, of course, is a separate variable that can be modified to point to other objects. So references always refer to something, whereas pointer can be set as a null pointer. References can be reassigned, so once reference exists, the reference will remain to be the same. So in other words, let's say that we have a function, and in this function we create an object. Okay, and so then we can call, so this object exists in the local scope of the original function, such as main function or some other function. So this is where the object is created, and it resides right here. So there is a possibility to call another function which will have its own totally separate local scope of its own local variables, and instead of copying this object over, it's possible to pass a parameter which is a reference right here, just a reference to this object, which is very much like a pointer, so it contains the address of this object. Okay, however, all of these rules apply. So right here we can use this, this becomes basically a second name for the original name. So right here in the original context where this object was created, we have some sort of identifier that we use to refer to this object, like rectangle or name or something else. Right? So this is the original scope where this object is created. However, in the scope of another function, if we manage to pass a reference to this function, then it becomes a second name for the original object, and everything that we do with this reference will be modifying and updating this object just as if this object was the local object in a different function. So all of these rules are enforced, and we will see some examples of references on the next slide. Okay, so this is an example of using references. So the idea is, for example, the main idea is to use function swap and be able to exchange the values. So let's just take a look at the code example for the swap function. I already created an empty project for this section, and if you look at the Solution Explorer, I have an empty main file. So let's copy the swap function into our source file like this, and we'll declare function main as testing ground for this swap. So we'll just say return 0, and now because this function swap is expecting integers to be given to it, and we'll create two integers, int1 equals 1 like this, and integer 2 equals 2. And now we're going to call swap, and we're going to swap 1 and 2. And instead of printing all of these values, what I'd like to do is just to set a breakpoint inside the main function and build our program. Notice that I don't need any includes because I'm using only very, very basic facilities of the programming language here. And I'm going to start debugging session, start debugging. And as I'm starting debugging, I'm displaying my local variables. Notice that in the local scope of function main, we already reserved space for 1 and 2, but they remain uninitialized with some strange values like this. So I'm going to press F10 to step over these two lines, step over 2 times, and you can see that now initialization is complete. So 1 is 1 and 2 is 2. I can probably resize this to make it easier to see in the local variables. If you don't have it displayed, you can always go to the debug windows and display whatever you like. So there's locals, there's also automatic display of variables, but the locals is what I'm using right now. And so this is function swap. So this function swap is going to use 1 and 2, and it's supposed to exchange their values. So what is expected upon return from function swap is that 1 and 2 exchange the values. Okay, so let's press another F10 and just step over it and look. Both 1 and 2 have changed their values. 1 is now set to 2 and 2 is set to 1. So let's discuss how this works and how references play a role in our implementation. Okay, so we have two integers, right? So we have our main function. So it has its own local scope of variables like this, right? So this is where we have our variables, and there are two integers, integer 1 and integer 2, and so these objects contain these the values 1 and 2. In fact, let me kind of redraw this differently. I'd like to just draw boxes around the values themselves, right? Because these are imaginary memory locations which contain these two numbers. So then we call function swap on this line, and we supply names of our integers 1 and 2 and give them to a function which takes a reference to an integer and a second a reference to an integer. So when we do this, and when we provide 1 and 2 as parameters for this function to take, the actual parameters are 1 and 2, inside function swap, left and right become second names for 1 and 2. So imagine that we have these two integers. Okay, so I'll just redraw this the second time or the third time, right? So if in this function this integer 1 right here has name 1, which is attached to this, in this function, which is taking a reference to an integer, the name left is going to become simply a second name for the same object. The object is not copied. This function gets access to the original object. Likewise, the second integer, which is created by function main, is also passed to function swap, and here it will get access to the original object. Beyond that point, left and right basically become a synonyms or second names for the original names that we were giving our variables 1 and 2. And here what we do is basically we're creating an integer temp, right? So temp is an integer that we create inside function swap, and we copy the value from left, right? So essentially a copy of 1, because left is the second name for 1. So the value, in the first place, the value is copied right here into this integer temp, which is just a local variable inside function swap. Then we say right equals left. So we essentially assign from right, which is the second integer, right? So we essentially we copy from right to left, from right to left, from 2 to 1. So we make this copy as a second step. But because we're using names which are references, the update is happening on these original objects, not here. These are just references that are using that refer to objects populated outside of the scope of this function swap. And in the third step, we say temp equals right. So right, of course, is 2. So we complete this swap by taking the value preserved in temp and giving it to 2. So you see, in these 3 steps, basically the exchange is happening through this temporary variable. We preserve this, we update this, and then preserved value is assigned as a final step. And so this is why when we come back from this function, of course, the values of 1 and 2 are exchanged or swapped. And this is a convenient way to use references, because if references did not exist, and I will now stop my debugging session to demonstrate that perhaps what we could do instead of using references, we could use a pointer version. So a pointer version of swap would be using pointers, okay, like this. So this way, if we want to invoke a version of swap which is expecting pointers, so let's do it on the second line, we would have to take addresses of 1 and 2. In that case, left and right would not be references, they will be pointers to the values in our function. In other words, basically those will be pointers to the variables right here. So pointers to 2 and pointer to 1, like this. Now, of course, when using pointers and trying to access the original objects that pointers are pointing to, we would have to dereference every time we use pointer. So the pointer syntax actually requires more work than references. The references only require this ampersand to say that this should be a reference to an object. This also should be a reference to an integer. All right, both objects are integers, obviously. And from this point on, we use the names of our references just as if this code was written directly in the original function when both of these integers were instantiated in the original place. Now also notice that if I build this, okay, so now we'll be calling swap twice, but the first time compiler will use this version of swap, and the second time, of course, because we're taking addresses of objects, it will be matching this set of arguments with the version of swap that uses pointer version. And C++ allows overloading functions like this. Is called function name overloading. The function name overloading is an idea by the compiler that as long as we have the same function, regardless what's the return type, but if the name of the function is the same and yet the set of parameters is different in some way, more parameters, less parameters, or different parameter types like we have right here, it's permitted to use it like this. So let's build this one more time. I have already built it. I am going to press F5 to start debugging session. So once again, my breakpoint stops me right on this line. You can observe the values of my local variables. Local variables, of course, local variables in my current context of main function. So I'm going to press F10, F10, and on this swap I'm going to press F11 so that I would like to step into this function. I press F11 and you can see that I'm stepping into this function. I'm pressing F11 again, for instance, and you see how in the main function, of course, 1 and 2 were initialized to be 1 and 2. And now inside swap, left and right became second names for 1 and 2 respectively. And so left is 1 and right is 2. So you can see that even debugging environment really doesn't make much differences or or anything that presents presents anything different compared to main. It's exactly the same. Left and right now are set to 1 and 2. And of course, this function swap is not using its own data. It's using references to the two original objects which were given to this swap call to be used to refer to objects. And of course, temp we need for swap algorithm, so we step over and we do this work, but this work with left and right is actually happening outside of this function. So I'm going to press F10 one more time. We come back from the first version of swap, and now let's complete this. So I'm just going to press F10 one more time, and on this line I also would like to step into our context, and when I I press F11, it takes me to the second version of swap, because the second version of swap is using addresses to initialize pointers, and our compiler was able to determine that the best way to match this call is actually this function, which differs in the types of arguments that it receives. And the same work will be done here, so we just go create a temporary variable, but this time left and right are addresses of objects outside. So pointer is very much like a variable that stores an address, and reference, as you could see in this debugging session, is really just like alternative name to the original object, and this alternative name to this original object, which were passed as parameters to this function. So both swap functions work the same way, and reference internally, of course, also is holding an address of our integers, but its syntax is simplified. No need to dereference references. They dereference themselves automatically because they just like second name for integers that were passed by reference to this swap function. And second of all, if we're using this version of swap, which is expecting pointers and therefore needs to be provided with addresses, also if we're deciding that we want to, or we prefer to use a swap function that uses pointer parameters, then of course we're forced to use the ampersand to take addresses of our original integers and populate these two pointers with addresses to these integers. So both swaps work. Both swaps actually do the same stuff, but you can see the difference. And there are many places where C++ references really begin to shine, because oftentimes you just want to pass an object to another function. You want to avoid copying the original object, and using references is a perfect choice for that kind of situation. In most cases, when we create an object like a string of characters or dynamic vector of elements, like dynamic array of some elements, and we want to pass that to another function, of course doing it by reference is just really a great choice to make.